Stoichiometry. In this module, we will study about stoichiometry, general stoichiometric steps, mass-mass relationship, mass-volume relationship, volume-volume relationship, and limiting reagent. An introduction to stoichiometry.
I love to eat Maggi noodles.
Do you know what makes Maggi more tastier and a preferred choice over the other brands?
Composition is of great importance. A little change in the composition may give us a different product.
Stoichiometry. Stoichiometry is derived from the Greek words stoichion, which means element, and metron, which means measure. Jeremias Benjamin Richter from Germany first introduced the term stoichiometry in chemistry in the late 19th century. Stoichiometry deals with the relative quantities of reactants and products in the chemical reactions. Consider the following reaction. It gives the complete information about the reaction under consideration. It tells that 1 mole of zinc reacts with 2 moles of dilute hydrochloric acid to form 1 mole of zinc chloride and 1 mole of hydrogen gas. These stoichiometric coefficients are useful since they establish the mole ratio between the reactants and the products. General stoichiometric steps.
General stoichiometric steps are as follows. Step 1. The balanced chemical equation is written in the molecular form. Step 3. The atomic weights, moles, molar volumes of the underlying substances are written depending upon the nature of the problem. For those substances whose weights, volumes have to be calculated, the sign of interrogation is written.
A balanced chemical equation conveys the quantitative information which helps in a number of calculations. Mass-mass relationship.
Mass relationship. The mass of one of the reactants or the products is given, and the mass of some other reactants or products is to be calculated.
Steps to follow while solving a problem based on mass-mass relationship. In a mass-mass relation problem, the mass of one of the reactant or product is given. Step 2. Taking the ratio from the balanced chemical equation, we calculate the number of moles of the second reactant or product. Let us solve a numerical based on mass-mass relation. determine the amount of sulfuric acid, 75% by weight, which is required to decompose 0.5 mole of calcium carbonate with the help of the given data. The numerical can be solved by following the given series of steps. Step 1. Write the balanced chemical equation. Step 3. Calculate the molecular mass and mention the actual quantities. Step 4. Convert the moles of calcium carbonate in mass in grams. Therefore, on calculating, we get that 50 grams of calcium carbonate is decomposed by 49 grams of sulfuric acid. Mass-volume relationship.
In mass-volume relationship, mass volume of one of the reactants or products is given and the mass volume of the other is to be calculated.
Steps to follow while solving a problem based on mass-volume relationship. In a mass-volume relation problem, the mass of Step 2. Take the ratio from the balanced chemical equation to calculate the number of moles of second reactant or product. Solve a numerical based on mass-volume relation. What volume of hydrogen will be produced when 9 grams of iron reacts with an excess of sulfuric acid? The numerical can be solved by following the given series of steps. Step 1. Write the balanced chemical equation. Step 3. Convert grams of iron into moles. Step 5. Convert moles of hydrogen into volume. Thus, 3.84 decimeter cube of hydrogen will be produced when 9 grams of iron reacts with an excess of sulfuric acid. Volume-volume relationship.
In volume-volume relationship, the volume of one of the reactants or the products is given and the volume of the other is to be calculated.
Let us solve a numerical based on volume-volume relation. Calculate the volume of oxygen that is necessary. The numerical can be solved by following the given series of steps. Step 1. Step 3. Calculate the molar volume and mention the actual quantities. Therefore, on calculating we get that 5 liters of butane at NTP will require 32.5 liters of oxygen at NTP. What would you get if 2 slices of bread and a slice of cheese are combined together? How many sandwiches can be made if 6 bread slices and 2 pieces of cheese are available? We get 2 sandwiches and 2 breads are left.
The reactant that is entirely consumed and limits the amount of product formed by the completion of a reaction in a chemical reaction is called the limiting reagent.
NO and O2 react in 2:1 ratio in order to form the product. The expression for the identification of limiting reagent is as follows. Let us solve a numerical. In an experiment, a mixture of 0.5 mole of methane was burnt in 2.0 moles of oxygen in a sealed steel vessel. According to the balanced chemical equation, 1 mole of methane reacts with 2 moles of oxygen to produce 1 mole of carbon dioxide and 2 moles of water. Now, 1 mole of methane produces 2 moles of water and 0.5 mole of methane will produce 1 mole of water.
Limiting reagent. The reactant, which is consumed during a reaction and consequently limits the reaction, is called a limiting reagent. Let us take an example to understand how a limiting reagent limits a reaction. When atmospheric nitrogen and oxygen react at a very high temperature, nitric oxide is formed. Nitric oxide is quickly oxidized to nitrogen dioxide by atmospheric oxygen. The bulb on the left side of screen contains nitric oxide and that on the right side contains oxygen. In first case, 4 molecules each of nitric oxide and oxygen are present separately in 2 bulbs. When these are allowed to react, 4 molecules of nitric oxide react with only 2 molecules of oxygen and 2 oxygen molecules remain unreacted. The reaction stops when nitric oxide gets consumed, that is, nitric oxide limits the reaction and therefore it is the limiting reagent while oxygen in this reaction is in excess. In second case, 6 molecules of nitric oxide and 3 molecules of oxygen are present separately in 2 bulbs. When these are allowed to react, 6 molecules of nitric oxide react with 3 molecules of oxygen. There is no unreacted molecule in the bulbs. In third case, 6 molecules of nitric oxide and 2 molecules of oxygen are present separately in 2 bulbs. When these are allowed to react, 2 molecules of oxygen react with only 4 molecules of nitric oxide and 2 nitric oxide molecules remain unreacted. This time reaction stops when oxygen gets consumed, that is, oxygen limits the reaction and therefore it is the limiting reagent while nitric oxide in this is in excess.
Let's have a quick recap. Stoichiometry is the quantitative relationship among the reactants and the products. The problems involving these calculations may be classified as mass-mass relationship, mass-volume relationship, and volume-volume relationship. Limiting reagent is a reactant in a chemical reaction that is entirely consumed and limits the amount of product formed by the completion of a reaction.